Good evening, pre-algebra. This is your flipped lesson for November 30th, the last day of November. Not the last flipped lesson, I hope, but the last day of November. We're going to do some more of solving strange equations. Now, I know there's a couple of people going, I don't get it, I don't get it, I don't get it. Are you using your questions? Question number 1. What is my goal? And the answer to that is always the same. It's to get x alone, or the variable alone. All right, question 2. Ooh, there's an extra little thing there. What numbers are keeping x from being alone? What numbers are keeping x from being alone? It depends on the problem, but you have to answer that. Number 3. How are they attached to x? Your answer there always has to be one of these choices. It has to be addition, subtraction, multiplication, or division. Okay, and then question 4, back to blue. How do I undo that or those? All right, again, your answer has to be, you'll undo addition with subtraction. You'll undo subtraction with addition. You'll undo multiplication with division, and undo division with multiplication. The inverse operations, they are inverses of each other, meaning they undo each other. All right. Then the final question is, which do I undo first? And that is where we need to listen to Saddam. Did you get that, Megan? We need to listen to Saddam. Mike, were you listening? Saddam, which tells us to undo the subtraction and addition before we undo the division and multiplication. Ooh, what am I doing there? Okay, it's just the order of operations backwards. It's part of PEMDAS, right? The order of operations, but it's backwards. I expect you to have those questions written down and using them if you're having difficulty. All right, let's run through a real easy example. Let's say I have negative x over 5 plus 7, yeah, and we're going to let that equal 8. I'm going to run through my questions and then we'll get to the strange ones. All right, give me 1 second here. Okay, what is my goal? To get x alone. What numbers are keeping the x from being alone? Well, I see that there is a 5 here, and I'm even going to count it as a negative 5. And I see there is a 7 here. Okay, the 7 is attached by addition. The 5 is attached by division. Remember, a fraction bar means divide. Okay, which one am I going to undo first? 2. 2. Oh my goodness, I needed a little room to work, and I sneezed and everything moved. Very good. Okay, according to Saddam, I am going to get rid of the addition first. How do I undo addition? I've already said subtraction. How much am I going to subtract? What am I trying to get rid of? The 7. I will subtract 7 from both sides. Remember, the Great Wall of China. You have to do it to both sides, right? Okay, so my new equation becomes 1 equals, and on this side I have a negative x over 5. Is the x alone? No. There's a negative 5 still attached. Somebody's going to go, Mr. Lawrence, that negative's out in front. Doesn't matter. Remember, negative 1 over 2 is the same as negative 1 over 2, which is the same as 1 over negative 2. I can move that negative to the numerator, denominator, or in front of the fraction, and I do not change the value of the fraction. So when you start understanding about math, it gets a whole lot easier because you make math do what you want it to do, not you being a slave to what math wants you to do. I like it better. All right, I am going to undo this division right here by multiplying. I'm going to multiply both sides. I'm going to multiply by what I'm trying to get rid of. Well, I'm trying to get rid of a -5. So I'm going to multiply by -5. On the left-hand side, I'm going to write -5 as a fraction. -5/1. When I do that, the right-hand side very simply becomes -5. The left-hand side, the 5's cancel, but so do the negatives, leaving me with just an x. By the way, when they cancel in division, they turn into 1, right? Not 0. My answer is -5. I can check my work. Let me check my work. I shall check my work for you. -5/5. Wait, Mr. Lawrence, where is that 5 coming from? Right here. And I've actually made a small mistake because the fraction is negative to begin with. I need to stick another negative in there because x was -5. All right, and then I'll have to add 7 to what I get. Well, minus a negative is the same as plus a positive. Some people will say wop wop. All right, 5 divided by 5 is 1, plus 7 is 8, and look at that. That matches the original problem right there. I know I did it correctly. All right, let's look at another strange one, and then I'll give you a chance to try. Let's say we have 3x minus 2 over 5, and that's going to equal, let's go with 4. Okay, remember to undo this one, this 5 is mucking things up. I have to get rid of that 5 because it's dividing into the entire 3x minus 2, and I can't use Saddam until I get rid of that 5 to free things up. So to get rid of the division here, I will multiply by 5/1 on this side and times by 5 over on that side. When I do that, these 5's cancel, leaving me with the new equation of 3x minus 2, and that equals 20. All right, now I can go to Saddam due to my questions and say, well, let's see, my goal is to get x alone. I've got a 3 attached by multiplication, a 2 attached by subtraction. Saddam tells me, did you hear that, Darian? Saddam tells me to undo subtraction first. I'm going to undo subtraction with addition. How much am I going to add? The amount I'm trying to get rid of. Then I have to do it to the other side. Remember the Great Wall of China. Kind of looks like a snake. All right, so that gets me this equation, 3x, and that'll equal 22. Now I will divide each side, because the division undoes the multiplication, by 3. And if I do that on a calculator, I will get 7.3 repeating. If you are not a fraction wimp and you are good with fractions, you'll get 7 1/3. Either answer is acceptable. I'll even say x equals 22/3, but you have to be able to understand what you're doing. All right, let me give you a couple of those to practice. You can pause the video after you see them and then unpause it when you're ready. So practice problem A is going to be -2x plus 1 over 4, and that's going to equal 8. And practice problem B will be 5 minus 3x over 2, and that will equal 9. Okay, go ahead and pause the video. When you're ready, go ahead and look at the solutions. Okay, I'm going to work through the solutions now. I'm assuming you've already watched. The first thing I'm going to do is I'm going to multiply each side by 4, giving me the equation -2x plus 1 equals 32. The 4's had canceled. Now I just have a two-step equation. Saddam tells me to get rid of the addition first. I will. And I will end up with -2x equals 31. Now I'll get rid of the multiplication by dividing by -2 on both sides. And I will end up with x equals negative 15.5, 15 and 5/10 or 15 and a half. All right, very good. If you got that one right, give yourself a pat on the back. All right, problem B, I'm going to move up a little bit so I have a little more room to work. And I need to get rid of this 2 because it's mucking things up. I'll multiply by 2 over 1, multiply by 2 over there, and I will end up with, cancel, 5 minus 3x, that will equal 18. Saddam tells me to get rid of the addition first. Remember, this is addition. Why? Because it's a positive 5. If 5 is attached by addition. So I will subtract 5 from both sides. When I do so, I will end up with negative 3x, because those canceled, equals 13. I'm going to rewrite that over here. Negative 3x equals 13. Kind of divide out my work there. Now I must get rid of the multiplication by division. I'll divide each side by negative 3. X will equal negative 13 over 3, which is the same as 4 1/3, but it's negative. Or if you use the calculator, you'll get 4.3 repeating. Okay, very good. Next page, let's try another problem. A problem that looks like this. 2x plus 5 equals 5x plus, let's go with 14. All right, remember on this one, I want to get rid of the x. I've got x's on both sides. I'm going to get rid of one of them. I like to get rid of the smaller one. It keeps things positive, which makes things a little bit simpler. So I get rid of it by subtracting away 2x from both sides. Left-hand side turns into 5. Right-hand side turns into 3x plus 14. Okay, now I have a two-step equation. I've got a 3 attached by multiplication to x and a 4 attached by addition. I will subtract 14 from each side. Okay, 3x will equal negative 9. How did I know that? Because I know that 14 minus 5 equals 9. Therefore, 5 minus 14 must be negative 9. I don't know if you realize that. It's very simple. 5 minus 3 is 2. 3 minus 5, negative 2. It works that way every time. All right, back to the problem. I've got to get rid of this 3. It's attached by multiplication. I'll divide by 3. X will equal negative 3. Okay, now I'm going to give you two problems. The answers will pop up. I want you to pause, of course, try them on your own, and then you'll be ready. All right, so problem, let's call it problem C, and problem D. And problem C will be 6x minus 3 equals 4x plus 9. And problem D will be negative 2x plus 5, and that'll equal 2x plus 10. All right, go ahead and pause. I will work through the solutions really quickly. 4x from each side. 2x minus 3 equals 9. Add 3 to both sides. 2x equals 12. Divide by 2, leaving x equals 6. If you got x equals 6, that's awesome. All right, the solution for D is a little bit trickier. I'm going to add 2x to each side. And those will cancel, and I will get 5 equals 4x plus 10. I will subtract off 10 from both sides, leaving me with 4x equals 5 minus 10. Well, let's see, 10 minus 5 is 5, so 5 minus 10 must be negative 5. All right, now I need a to divide by 4 on each side. And so x is going to equal negative 5/4, which is the same as negative 1 1/4. It's also the same as negative 1 25/100. Any one of those answers is acceptable. Okay? All right. That's Mr. Lawrence's lesson for today. You'll get some practice tomorrow in class. Good night, everybody.